In this topic, we will understand the methods to implement natural and mechanical ventilation systems for various building applications. The most prevalent and conventional method for introducing fresh outdoor air and replacing inside stale air in any building is through natural ventilation. This is achieved by providing openable windows, vents, louvers, etc. on the building facade to achieve optimum airflow rates to maintain good indoor air quality levels. However, since the modern buildings are constructed airtight, to reduce the infiltration load on the air conditioning equipment, an effectively designed mechanical ventilation system is required for energy efficient buildings. The appropriate ventilation system must be selected for a specific application depending upon the climate, building structure and process requirements. Methods of ventilation, supply and exhaust of air to space may be done naturally or mechanically or combination of both. Some of the commonly used ventilation strategies in buildings are listed below. First one is natural supply and natural exhaust of air, natural supply and mechanical exhaust of air, mechanical supply and natural exhaust of air, and mechanical supply and mechanical exhaust of air. Now, let us see all the above ventilation methods in detail. Natural supply and natural exhaust of air. As the name implies, there are no mechanical fans involved in the system and consumes zero energy. It uses louvers, vents, openings provided on the building facade to enable natural movement of air throughout the building due to density differences or buoyant forces due to temperature differential. It is most suited for non-critical applications such as ventilation of corridors, covered car parks above ground level, etc. Natural supply and mechanical exhaust of air. As shown in the illustration, the indoor air is mechanically exhausted through an extraction fan. Due to this, a negative pressure is created within a space which results in a pressure difference between indoor and outside air. Due to this pressure difference, the outside air will be drawn into the space which is at negative pressure through openable windows, louvers, vents, leakages, etc. If space generates any hazardous contaminations which cannot be directly exhausted to the environment, an appropriate filter needs to be provided in the exhaust air stream before it is expelled into the atmosphere. Toilet ventilation typical layout. This figure represents a typical layout of a toilet ventilation system. Natural supply and mechanical exhaust air methods are used for toilet ventilation in this example. As shown in the figure, through the extract grill, air from the toilet enters the extract ductwork which is connected to a common ventilation riser. Generally, all floor extract ductwork is connected to a ventilation riser that leads towards the terrace level. At the terrace level, an exhaust fan is connected to this ventilation riser which finally expels the air into the atmosphere. Toilet entry doors are provided with door louvers or door undercuts, or in some case transfer grills is provided. Fresh air enters through door louvers, transfer grills, door undercuts from the surrounding areas. Generally, the toilets are maintained at slightly negative pressure compared to the adjacent area so that the odors from the toilet do not spread to the adjacent areas. Advantages of natural supply and mechanical exhaust system. Now, let us discuss the benefits of natural supply and mechanical exhaust of air. By providing a ducted exhaust system, we can remove localized contamination at the source. Steam, odor and heat can be removed at the source using this method. In kitchen exhaust application, since a large number of airborne particles, grease, products of combustion, fumes, smoke are generated, these cannot be released directly to the atmosphere. Hence, we need to have some scrubbers to filter the exhaust air before discharging into the atmosphere. Many industrial processes also release a lot of toxic gases, particulates, etc. Hence, this exhaust needs to be filtered before releasing into the atmosphere. This method of ventilation is mostly used for dirty industrial processes, kitchens and toilets. Heat recovery systems can be employed to recover the chillness in the exhaust air stream to pre-cool the fresh incoming outdoor air. The next method of ventilation is mechanical supply and natural exhaust of air. As this name suggests, the outdoor air is supplied to a given space by mechanical equipment and shall be exhausted from this space naturally. The mechanical fan is used to supply outdoor air to this space as illustrated in the diagram, which causes positive pressure to be created within the space. As a result, indoor air begins to leak out through the doors, windows, vents and other leakages. In locations where outdoor air is polluted, filters are used in the supply air equipment to remove the contaminants and dust particles from the outdoor air before supplying to the space. This will ensure that indoor air quality criteria of that specific application is always met. In cold climates, an electric strip heater can be installed in the supply air stream to ensure the air supplied to the space is in comfortable conditions. As we discuss the basics of mechanical supply and natural exhaust system, we will discuss the merits and demerits of the system. The following are the benefits we can get by adopting this method of ventilation. As we can provide the heater in the supply air path, air can be heated to any desired temperature before it is getting supplied to the room. Air also can be filtered before it enters the building to meet the IAQ requirements. Using the fan, we can control the volume of air being supplied to the space. This will help us achieve good control of temperature and air movement within the space. Air duct distribution can be planned within the space, which will further help us to achieve proper air distribution within this space. Disadvantages of mechanical supply and natural exhaust of air. Heat recovery of exhaust air is not possible, cannot be used in highly hazardous applications where exhaust air needs to be treated or filtered before discharging into the atmosphere. Mechanical supply and mechanical exhaust of air, which is a balanced system. As its name suggests, the air can be supplied to the space and exhausted from the space simultaneously using a mechanical equipment. This method provides the most effective ventilation and helps us to have very accurate control over the airflow rates. As this requires mechanical equipment for both supply and exhaust, it is the most expensive method and comparatively requires more space to accommodate the fan and ductwork and also consume more energy. Using this method, we can maintain the space at neutral pressure, positive pressure or negative pressure by changing the airflow rates of the supply and exhaust air streams. Recirculation of air is not permitted if the air is heavily contaminated. In kitchens, toilets, smoke filled spaces, operation theatres, etc., where the exhaust air contains odors or contaminants, 100% exhaust is recommended and no recirculation is allowed. Mechanical supply and mechanical exhaust of air. The figure represents the basic schemes of mechanical supply and mechanical exhaust of air, which is a balanced system. As shown in the figure, fresh air is passed through the filter. This depends on the application and the quality of outdoor air. The filtered air is made to pass through the air distribution ductwork and air terminals, and it is distributed uniformly throughout the space. Normally, air recirculation shall be avoided to ensure the indoor air quality levels within the space are maintained and do not cause any harmful effect for occupants within the space. Here, the indoor air is exhausted using a mechanical fan. If the exhaust air is relatively clean, some portion of exhaust air can be used as return air and supplied back to the space after mixing with the fresh air through a recirculation duct. If the air is highly contaminated, recirculation is not allowed and 100% exhaust air must be expelled to the atmosphere after the filtration process.